Hey guys, welcome back to the programming interview series where we'll be breaking down interview programming questions step by step. For this series, we'll be working on a website called Codility, which has lots of free practice questions to choose from. The question we'll be working on today is Codility Lesson 3, Question 1, Frog Jump. So let's start by reading the question. A small frog wants to get to the other side of the road. The frog is currently located at position X and wants to get to a position greater than or equal to Y. The small frog always jumps a fixed distance d. So we have to count the minimal number of jumps that this small frog must perform to reach its target. So the question is, we have to write a function, class solution, that given three integers x, y, and d, returns the minimal number of jumps from position X to a position equal to or greater than Y. So for example, given X equals 10, Y equals 85, and D equals 30, so an initial position of 10, end position of 85, and a jump distance of 30, the function should return 3, because the frog will be positioned as follows. So we can see here that the frog starts at position 10. And his first jump will travel him a distance of 30. So he'll go from 10 to 40. Then on his second jump, he'll travel 30 again. So from 40 to 70. And then finally on his third jump, he's going to go from 70 to 100, which is past his point of his endpoint of 85. So you can see that in total it takes the frog 3 jumps to get to the final point. So now let's jump into our Eclipse editor and we're going to start working on the problem. So right away we can open up our class frog jump, which will be the solution to this problem. And we'll initialize our method here. So we have public static int solution, taking 3 parameters, integer x, integer y, and integer d. Let's remember here that x is the starting position of the frog, y is the endpoint, and d is going to be the jump distance. So next we can initialize distance. So double distance equals y minus x. So what this variable is, it's going to be the distance is the distance that the frog needs to travel. So from the starting point to the end point is how far the frog has to go throughout the entire question. Next, we're going to initialize another variable here, integer jumps. And what we're going to do here is we're trying to calculate the total number of jumps that the frog has to take to get to the final point. So jumps equals distance divided by d, which is how far he jumps in a jump. And so then we're going to use the math.ceiling function. So this is a way to round the answer to the nearest whole number while rounding up. Okay, so we're going to round distance divided by d to the nearest whole number above, and we're going to cast it to an integer. So ceiling functions returns the double value that is greater than or equal to the argument and is equal to the nearest mathematical integer. So let's say we have a value of 3.5. We're going to want to take the greater value. So we're going to go up to 4 because let's say he jumps 3.5 jumps. Well, he actually needs 4 jumps to get to the final position. And that is going to be basically the whole calculation for this question. So now we return jumps, which is how many jumps the frog did throughout the question. And then we can go to our main method here and do a system.out.println. And we're just going to want to do solution and enter in some values. So let's do 10, 85, and 30. And we'll see what this gives us as an answer. Proceed. Perfect. and it gives us 3. So this means that the frog had to jump 3 times to get from 10 to 85. So let's try some more tests here. Let's change 85 to 155. So the frog has to travel to 155. And we see it gives us 5. So he has to jump 5 times with a distance of 30 to get from 10 to 155. Let's try changing the jump distance. So let's up it to 40. And we'll see that he now only has to jump 4 times to get to the final position. So now that we tested our program here on Eclipse, we're going to want to transfer it over to Codility. So let's just copy in our solution method. And we're going to open up the website here. We'll copy it in the main solution method, or class, sorry. And we'll run the test. We'll see that the compilation is successful. So now we can submit our task. And in just a moment, we should be able to see that our question was solved correctly. Oh, so it looks like we got a perfect score of 100%. So now let's go down. Oh, it's still being evaluated here. So, okay, there we go. So we got all the questions right. Perfect. And we got a detected time complexity of 0.1. So that is really good, actually. That means it's basically as fast as it could be for this solution. So with the result, we got a big O of 0.1. So 0.1 is actually the fastest a solution could be. So it means that it runs in constant time, no matter how big your problem becomes. So this is always what you're aiming to get when you're trying to solve these problems. That's going to be the end of this tutorial. As always, leave a like, leave a comment down below if you have any suggestions on content you'd like to see. And yeah, see you guys next time for the next tutorial.